Hi, in this video I'm going to show you the concept of Pythagorean theorem. So let's first consider a triangle, but this time a specific or a special triangle, and that is a right triangle. So one characteristic of a right triangle is that one of the angles is a right angle. So that makes a triangle a right triangle. Now, so let's call this side A, let's call this side B, and let's call this side C. An important formula that relates the side A, B, and C is A square plus B square is equal to C square. And this is a very useful formula. Most of the time, or in most cases, you will encounter a problem wherein you have to find one of the sides of the triangle. So as long as you know the measure of the two sides, it can be A and B are known and you want to find C, or A and C are known and you want to find B, or say B and C are known and you want to find A. So this formula is very useful. So let's put this on the side. Now, so I'll give you an example. So say I have this triangle here. I know this to be 3, I know this to be 4, and I want to find this side. So since we know that A square plus B square is equal to C square, then A can be any of these two sides. So I can set this to be the A, I can set this to be the B. So that means 3 square plus 4 square is equal to C square. 3 square means 9, 4 squared means 16, and this is C squared. Adding 9 and 16 will give you 25 is equal to C squared. And to find the C, you get the square root of 25. And that is equal to 5. So that's how you solve this. Okay? Now, let's use another problem. So suppose I have this, and say this time I know this to be 17, and say I know this to be 15. Now in the equation A square plus B square is equal to C square, the C is always the one opposite the 90 degrees. The 90 degrees, and this is what we call the hypotenuse. Sorry for not giving you the name beforehand, but since the side now missing is the one that is not opposite to the 90 degrees, then we can set that to be as B. So we can set A to be 15, so that means 15 squared plus B squared is equal to 17 squared. Now you have the option to simplify this right away, but I can do it this way: 17 squared minus 15 squared. Just compute for the value for each. 17 squared is 289. 15 squared is that's 125. So subtract the 2, that's 4, and this is 225. So this is 64. So that means B is equal to the square root of 64, and b is equal to 8. Okay, let's put this here first, this on the side. We'll get these things. Okay, that's nice. Okay, so let's continue. So this time let's make an example wherein this one is missing. If you're used to this kind of orientation, and say I know this to be 12 and I know this to be 13. So again, I can set this to be A, I can set this to be B, and I can set this to be C. So A square plus B square is equal to C square. So A is unknown, so let's just write that as A squared, B squared is 12 squared, and then C squared is equal to 13 squared. So you should know the squares of some numbers. This is 144 and this is 169. And then this means A square is equal to 169 minus 144. And this is basically 25. So if A square is equal to 25, that means A is the square root of 25. Technically it's plus or minus, but we're computing for the sides of the triangle, so you can just take the positive number. So this is A equals 5. So the side missing here is equal to 5. Okay? So that's how you do this. Okay, let's get this one. Let's make this larger. See, I can make this larger. It's great, right? Okay, so you have this a while ago. So just a recap. Okay, so just put it here. And then this one, another case. Okay, let's put this here. And then this one. See. Looking too small. Okay, there we go. Okay, that's nice. Let's make this smaller. Let's put this here. Okay, that's it.